Hi guys, welcome back to the channel. Jag here, and in today's class with popular demand, we are going to continue with our grade 9 math content. And today's class is going to cover, so we're still on the geometry section, and we're going to move on to the volume of a sphere. Okay, so I'm going to write down the formula here on the board. Okay, for the volume of a sphere. Okay, so it's 4 over 3 pi r, okay, cubed. Okay, again, you don't need to memorize all of these formulas. You notice in each of the videos, there's basically a new formula for each of the new 3D shapes. Okay, so again, the teacher will provide all of the formulas for you. Okay, but again, that means that some of the questions might be just a little bit harder, and they might be more of application or thinking questions. All right, so let's get started. We are going to try an example, okay, from the textbook. So let's start off with something really simple. It says calculate the volume of each sphere and round to the nearest cubic unit, which means I'm rounding to the nearest whole number. Okay, so over here I have the radius is given. Okay, the radius is 14.2 centimeters. Okay, and I'm just looking for the volume. Okay, so we're going to plug it into this formula. Okay, again, for the value for pi, we're going to use 3.14. Okay, and the radius is 14.2 centimeters. And it's going to be cubed. Okay, again, I'm just going to put it into my calculator here. Okay, so again, when you're doing 14.3 or 14.2, and you're cubing it, it's to the power of 3. Okay, so if you want, I could do 14.2 times 14.2 times 14.2, and you're doing it 3 times. Okay, and then times it by pi. Okay, when you're doing the actual fraction, how you could do it in your calculator is just times it by 4 and divide the whole value by 3. Okay, so this is the value that we are getting here. So 11,000, okay, 987. Okay, it says the nearest cubic unit, and we're getting 11,987. Let me write the decimal so everyone can see that. Okay, 0.63. So if I'm rounding that to the nearest whole number here, 11,988. Okay, so because the 14.2 was in centimeters, okay, my answer is going to be centimeters cubed. Okay, so I'm just going to box my final answer here. And again, because this is the volume, okay, your units have to be cubed at the very end. All right, are there any questions so far? Good. With that, let's go to the next example here. Okay, so I'm going to take out just the numbers, and let's keep the formula for the sphere on the board. Okay, so again, I'm going to read the question out loud, and this is kind of like an application question. Okay, so a golf ball has a diameter of 4.3 centimeters. Let's write it here. Okay, which makes sense. Okay, and it's relative to how small the golf ball is. Okay, calculate its volume to the nearest cubic centimeter. So again, we have to make sure we are rounding it to the nearest whole number. Okay, so when I'm looking for the radius, I'm going to do 4.3 divided by 2. Okay, so again, I'm not going to round the radius. I'm just going to put 2.15, okay, centimeters. Again, the diameter goes all the way across the sphere from one end to the other. When you divide it by 2, that is equal to the radius. Okay, so everyone should make sure that they are not just plugging in the diameter into this formula. In the formula, I can only plug in the radius. All right, so with that, it's 4 over 3. Okay, I'm going to multiply it by pi. So I'm just going to put 3.14. And the radius that we calculated here is 2.15. Okay, again, to the power of 3. Okay, so that is you multiplying 2.15 by itself, okay, 3 times. Okay, or you can just press the power button and then press 3, and it should give you the same answer. Okay, times it by pi here. And then again with the fraction, what I always do is I multiply it by 4, and then I press the equal sign in between, and then I divide it by 3. Okay, so we are getting 41.61. Okay, we're going to round this to the nearest whole number, okay, which is 42. Okay, the 4.3 here was in centimeters. My final answer is going to be in centimeters cubed. Okay, and again, just box your final answer so the teacher can see that. And this is always how you should be writing out all of your answers. Okay, start off by writing out the formula that you are going to use, and write the formula before you plug in all of the values. Okay, and I can show just like this one step in between where I plugged in the values, and then you're just putting it in your calculator, and I can state whatever the final answer is. Okay, and so I just wrote 2 steps here just to show you how we are doing the rounding. Okay, you do not need to do that. You could just write your final answer at the end. All right, anyone have questions again after this second example? Okay, good. So with that, we're going to try one last example here. Okay, so I'm going to take this off. And again, the reason we are trying this example is it is a very common question, okay, within this unit. And again, you might actually see a question similar to this one on the EQAO. Okay, so let's go through this example together. Okay, I'm going to read it out loud. So a spherical gemstone just fits inside a plastic cube with edges of 10 centimeters. And first we are calculating, so I'll put A here. First we are calculating the volume of the gemstone. And again, so the gemstone is basically a sphere here, to the nearest cubic centimeter. Okay, so basically the gemstone fits inside this cube. So I'm going to draw out the cube here. Okay, so say the cube looks something like this. Okay, and the gemstone fits exactly inside. Okay, so you see how I drew it here? It's basically touching all of the edges of the cube itself. The side of the cube, the length of this is 10 centimeters. Okay, and because it's a cube, it's 10 centimeters for the length, the width, and the height. Okay, so first we're going to calculate just the volume. Okay, the volume of this gemstone, which is the sphere. So that's what we're going to start off with in part A. Okay, so if everyone notices here, the diameter of the sphere is going to be 10 centimeters. Okay, to find the radius, I am going to do 10 divided by 2, which is equal to 5 centimeters. Okay, does everyone see that? So there are some assumptions that we are making here, because it says that the gemstone fits exactly inside this cube. Okay, so we're just assuming the diameter of the gemstone is 10 centimeters. When you divide it by 2, the radius is equal to 5 centimeters. Okay, does everyone see that? All right, so we're going to just plug it into this formula. Pi is 3.14, okay, and the radius is 5 centimeters. All right, to the power of 3, okay, so again, multiply 5 by itself 3 times. Okay, we're going to times that by pi. And again, I'm going to do times 4 divided by 3. Okay, it does not say what we need to round this to. Okay, so we will just round it, okay, to 523. This is in centimeters, so this is centimeters cubed. Okay, does everyone see how to do that? So here we are just looking for the volume of the gemstone in part A. Okay, so I'm going to take this off here. So we are going to try part B on this side. Okay, and part B says how much empty space is there. Okay, so again, I have to find actually the volume. Let's put the volume of the box. Okay, and because the box is just a cube, okay, don't put length times width times height, because this is the volume of a rectangular prism. Okay, so whenever it's a cube, I can just put side times side times side. And again, some teachers are picky. I would write the formula like this whenever it is a cube. And the reason is all the sides are basically the same. Okay, in this example, all the sides were 10 centimeters. So we're basically doing 10 times 10 times 10. Okay, again, put it on your calculator. Again, there's only 3 zeros here. So this is going to be 1,000 centimeters cubed. Okay, and now I'm looking for basically the empty space, like how much space is within the box not considering where the gemstone is taking up that space, okay? So we're gonna write it on the bottom here. So I'm gonna put volume of empty space, okay? So what do you think we are doing here? I have the volume of the box, okay? Then I also have the volume of the gemstone, and we're going to just subtract these two numbers, okay? So I'm going to do 1000 minus 523, okay? Let's put equals here. So we're going to subtract this, 523, and we're getting 477, okay, centimeters cubed, all right? And so this is basically my final answer. This is the amount of empty space in terms of the volume that is there in the box after you put the gemstone inside. Okay, so I hope everyone can see how to do this question. All right, make sure you're trying a lot of practice questions in this section as well. There are practice questions that are similar to this one. And again, this is most likely the question that the teacher will put either on like a quiz or like the unit test for sure. I would make sure I know how to do this question. And you can see that it is basically like an application question. It could be a thinking question. I kind of have to think about my answer here. Okay, and there will be a lot of questions where there is a one 3D shape put into another 3D shape, and then you're calculating the amount of empty space, okay? So when you do that, again, make sure you're finding the volume of each of the shapes separately, and then you need to just subtract the two volumes from each other, and that is the amount of empty space, all right? So that looks good, and that brings this video to an end. And again, today we covered the Math 9 content from the textbook on the volume of a sphere. I hope everyone enjoyed this content, and if you did, please make sure you're clicking on the like button below and subscribe to the channel. And I will see everyone next time. Thanks, bye.